Thank you, 2,000 people. Okay, now when I see you in such number, it reminds me of something funny that happened a couple of days ago at work. Me and one of my colleagues were speaking, and he was asking me, are you nervous about the conference? How are you feeling? Because it's my first time that I will speak on such a conference. And I was like, we are both trainers of some development academies here in Skopje, and I was like, it's the same thing. We speak a lot of times in front of a lot of students, and it should be the same, right? But now when I pop up on this stage, man, it's completely different world now. So if you see my knees shaking, my hands shaking, you know the reason. Just joking. At least I hope I am joking. Okay, so as lucky winner to be able to open this year conference, the DevCon conference, I want first of all to thank you all for coming in this number, and I hope you're going to have a great time during the day. Now, what I'm here to speak about is actually something that we are seeing from the slide. We're going to introduce ourselves to AWS Serverless architecture. Of course, first we're going to speak what actually serverless is, and after we're going to be more focused on the AWS Serverless architecture. But first thing first, let me take this. Let me introduce myself. I am Goce Kabov, currently working as a full-stack developer in Melon, also trainer at CDC Academy, more specifically for web development. And let's start. First of all, before starting to speak anything, I want to ask you, how many of you know what serverless is actually? So if you know, feel free to raise your right hand only. I don't accept left hand. Okay? I see a good amount of people that actually are aware of what serverless is, which makes me very happy, and I hope at least at the end we're going to have some good questions. And now, for the ones that actually are not aware what serverless is, why I'm asking this question? Because first time when I heard about serverless, first thought that came in my mind is, okay, am I actually able to create an application and host it somewhere without any servers? And as you might guess, this is not the correct answer, which leads us to this definition: serverless is not equal to no servers. This means that if you're using serverless architecture, we don't actually need to deal with any servers, or that doesn't mean that there are no servers behind the scenes. Of course, at least at this moment, there must be some servers, but of course, maybe in the future this might change as well, who knows. Okay, and now, you might be asking, okay, if serverless is not equal to no servers, to what is equal serverless? Well, it depends who do you ask. Why? Because a lot of IT professionals can interpret serverless in different means. For each IT professional, serverless might mean something else. But no matter who do you ask, there are 4 key concepts about serverless. And we're going to see them now on this slide. And as you can see, by serverless, there are no servers to provision or manage, but that doesn't mean that they don't exist. They exist, but we as developers, we don't need to care about managing, scaling, so on and so forth. Second, we pay only for value, or we can say it with other words, we don't pay for being idle. I'll give you an example. Imagine that you have an organization that is working from 9 to 5, and you have application that is used by your employees, right? And now, you don't want to pay for that application anything after 5 o'clock. You want to pay only while the application is being actively used by your employees, right? So actually that is the second concept. We pay only for value, which actually serverless provide to us. Next one, scales with usage. Again, example. Imagine I have today like 1,000 customers, right? So I have, let's say, a couple of hundreds of thousands maybe requests coming to my applications, and tomorrow all of that increases, all of this number increases. So with serverless, we don't need to take care of scaling our application. This is going to be automatically provided for us by the, of course, platform that we're going to choose to pick where we're going to actually implement the serverless architecture. And the last concept is availability and fault tolerance built in. Yeah, of course, whenever we create an application, we want to be highly available in all around the world, so a lot of people can actually become our customers. Okay, let's speak a bit about the serverless benefits. Of course, there are some negative sides as well, but because I'm here to promote serverless, I will speak at the end for them, not at the moment. So as you might see, we have greater agility, we have less overhead, better focus, increased scale, more flexibility, faster time to market. Why are these benefits of serverless? As we have mentioned, we don't need to deal with any managing servers, scaling application, anything related to that, we can freely focus only on our business logic and provide the development code only for the business logic, which of course saves us a lot of time. Okay, now let's focus more on the AWS side, and of course, how we can create actually application which will follow some serverless architecture. So we can take a very, very simple architecture design, as we can see on the image. So to be able to came up with this architecture, we of course need to use some of the AWS services, such Amazon S3, Amazon API Gateway, AWS Lambda, and Amazon DynamoDB. Because we are limited on time, I would love to speak in details for all of these services, but the main focus, as I mentioned, we are pretty short with time. Our main focus will be placed on AWS Lambda. Why? Because we as a developer, we are most interested about that service. That is the service where actually we provide our code that we want to be executed at the end of the server. But briefly, what is Amazon S3? Amazon S3 is an object storage service where actually we are able to place some of the data, to store there some of the data. We can store there very different kind of files, multimedia files, images, CSS file, JavaScript file, JSON file, HTML file, all of the different kind of files, and those will be saved there as objects. A very common use case in practice is we take our application, the front-end application, because we all know that the front-end application is constructed at the end when we build the application from HTML, CSS, and JavaScript files, right? We take all the application, we put it on the S3. In front of the bucket, in the S3, we can set some DNS servers. One of the mostly used services from AWS, which behaves as CDN, is CloudFront. Of course, I don't have time to speak about, but if you have any questions related to it, feel free to ping me privately message. I will be very happy to answer all of your questions. After that, Amazon API Gateway, just like any gateway, right? I assume all of the backend developers are aware what is the gateway, a middleman between our server, our database, and our clients. Which means whenever a user makes a request, before that request to come to our Lambda, we are validating that request, authenticate, doing whatever we want with that request. If everything is successful, after that we delegate the request to the Lambda. And now, as you can see from the presentation, Amazon API Gateway is an AWS service for creating, publishing, maintaining, monitoring, securing REST, HTTP APIs. What is a bit newer implementation, their new feature, is at the beginning, the gateway didn't accept WebSockets. We're going to discuss why that was an issue, but after many requests from the developers, even they created an API that accepts actually, that is working with WebSockets as well. And this gateway, what is its job? Its job is to handle all of the tasks that are involved in accepting and processing up to hundreds of thousands concurrent APIs calls. And of course, these tasks include traffic management, authorization and access control, monitoring, and even API version management. And together with the AWS Lambda service, API Gateway, both of them forms the up-facing part of the AWS service infrastructure. So these two are the main services that we are able to use whenever we want to achieve some serverless infrastructure. We have mentioned that we are going to speak mostly about AWS Lambda. We are now saying that actually together with AWS Lambda, API Gateway are the two up-facing part of the AWS serverless architecture. So I assume you might be questioning yourself now, okay, what the hell is AWS Lambda? Well, again, a different service provided by AWS, and it's a compute service that lets you run the code without provisioning or managing any servers. And now, the Lambda service itself, it sits on the top of the three concepts: event-driven compute, functions as a service, serverless functions as services. The event-driven compute concept aligns with the thinking about different individual actions, capabilities, flows that actually we are providing to the user to be able to interface with our application. So we can take all of these different capabilities and divide them into individual events. And now from the other side, the event model itself aligns with the ability to being able to respond to those specific events that happen. And which leads us to the second concept, and that is functions as a service. What does this mean? This means that we can provide an application code that will be connected with the events that are caused by user interaction, and of course we will be able to answer to all of those events in appropriate way that we want to achieve, of course. And in the middle of all of this concept is the serverless functions as a service, which is actually the AWS Lambda service, which meets all of the four main concepts that we talked previously about the serverless, and that is we don't need to provision or manage any services, we don't pay for idle, we pay only for value, it comes with automatic scaling, and as well, by default, it's very high, the availability of it is very high. Okay. Now, what is so special about Lambda? What they are handling behind the scene for us? Because when you speak about the Lambda, you know, it's like, okay, we provide there the code and that's it. Well, a lot of things are going on behind the scenes. As the Lambda service itself, for us, is managing, let me use this laser, load balancing, auto-scaling, handling failures, security isolation, OS management, managed utilization, plus many, many more things, which of course we don't have time at the moment to discuss about. Okay, one important thing to understand when you speak about Lambda is that the Lambda itself, it doesn't live in a vacuum. It lives in something that is called serverless application. Each serverless application is constructed by 2 or 3 components. The main 2 components are the event source component and the function, the Lambda itself. Plus, as addition, we can attach to that a lot of different services. It doesn't even matter if those are AWS services or maybe even some other custom services that actually we can reach directly from a Lambda. And we talk about event source. What can be the source that actually will cause the trigger of our Lambda? It can be a lot of different reasons. Right? There are, I assume, more than 40 services, AWS services, that are able to trigger some specific Lambda that we're going to configure. Some of the reasons are changes in data state, requests to the endpoints, changes in resource state, and plus any more. When you talk about the function, you as a developer, I assume you're interested in one very specific thing. Okay, I am a C# developer, I am a JavaScript developer, I am a Python developer. What kind of languages actually we are going to be able to use whenever we're constructing the Lambdas? I have a positive answer for you. It accepts a lot of different languages, like Node.js, Python, Java, C#, Go, Ruby, and lastly, the AWS introduced the runtime API. With short words, what does it mean? You can bring any language that you want inside of the Lambda execution environment. Okay, when we talk about invocation of the Lambda, mainly there are 3 different ways how we can invoke a Lambda. Synchronous or a push-based model, asynchronous event model, and stream poll-based model. When we talk about the synchronous, the example that we already gave, we are having an Amazon API gateway, we receive a request there, and from there actually, we are going to trigger a specific Lambda that some code will be executed behind the scenes. And of course, this is synchronous. Why? Because the client is waiting for response. The asynchronous event-based model is actually, imagine we're having Amazon S3, right? There, I have already mentioned, we're able to place some files. Imagine that whenever there is a change in specific bucket, let's say a new file was added, I want to trigger some email. I want some email to be sent to the admins, let's say, so they will be informed that, hey, listen, there is new file uploaded. Actually, we can configure in that way the Amazon S3 to be able to trigger the Lambda specific Lambda function, and there we're going to have any information about the file that has been uploaded, and of course do whatever we want after that. And the last, the stream poll-based model, actually is literally as pulling changes. For example, imagine we're having Amazon DynamoDB, no SQL database, no relational database. And now, again, the same example. We're having, let's say, users table. Whenever a new user is created, in that specific table, we want to send welcome email to that specific user, right? So we can configure a Lambda to listen for changes in that specific table, and whenever we catch some change in that specific table, we are going to execute some code against that specific record. It doesn't matter if it's a newly added record, it doesn't matter if it's modified record, or it doesn't matter if it's deleted record. We're going to catch all of this information and perform some actions against it. Okay, a very crucial topic that we must discuss whenever we're talking about Lambda is actually the security. or with other words, the Lambda Permissions model. Whenever we are talking about security, we need to think about two main things. And that is what our Lambda, or which services our Lambda is going to be able to communicate with. And the other side is, of course, the second thing that we must think, who is going to be able to contact our Lambda, who is going to be able to make an invocation of our Lambda. So, with that being said, we have execution policies, which actually define what AWS resources or API calls can these functions access. And there are different ways how we can achieve this, how we can give our Lambda permissions to access different services. Usually that is done via IAM or Identity Access Management Service, which is another service coming from AWS side, with which we can define policies, with other words, easy words to understand. We are going to create some policies that are going to give access to our Lambda to contact other services. And the other thing is the function policy. With these policies, of course, we define who is going to be able to invoke our Lambda that we have created. When I have already mentioned about the IAM policies, how they will look, actually, they're simple JSON files. As you can see here, we're having a IAM policy, and in that policy, we can provide different statements. With the different statements, actually, we can provide different capabilities of our Lambda to reach to other services. From the picture, you can see, for example, for this Lambda, we are having two IAM statements. With the first statement, we are actually allowing the Lambda, this action to list all of the buckets, where, in which resource, in some S3 bucket named confidential data. And also we're giving one more permissions to the Lambda, which action to get a specific object, from where, from which resource, again S3, with again the same bucket confidential data, but also here we have the Saradian, which means all of the files and folders inside of it as well. Okay, no demo, no fun, right? Okay, let me switch. Duplicate. Is it okay? Nice. Test, okay. So let me show you actually how quickly we can start an application using AWS and being able, all of you, to access it right now on the mobile phones in less than 5 minutes. So here I am in AWS console. I have logged with my account. Okay, this is not expected. I guess my token. Not good, not good. Okay, nice, good. Okay. Let's go inside of the AWS console. And here, let's search for the Lambda service. Okay. And let's create a new Lambda function. It's going to be Node.js 18. Everything should be the default. Let's just create it. It will take a couple of seconds to be created. Nice. And now, what we can do with this Lambda? Well, first of all, here we are going to see the source code, the code that is going to be executed whenever this Lambda is triggered. So it's a very basic implementation. We're just returning back a response with status code 200 and body JSON string eval hello from Lambda. Let's change this hello from DevCon. And I will just deploy this change. Okay. And now let's test our Lambda, right? So I'll create a new event. Let's name it test event and click on the test. I see execution function succeeded. And here I can see some details about the execution, how long it takes, how much resources were used while the Lambda was invoked. And here is the response from this specific Lambda. So what happened behind the scenes? Because we see something happen, but we don't know actually what happened behind the scenes, right? So whenever we trigger the Lambda services itself accepts the event, pulls the Lambda and our code inside of some execution environment, pull the code, started the execution environment, executed the Lambda, everything went okay. Imagine there are a lot of things that happened, but it was very, very fast. You can see the duration was 7.28 milliseconds. But this is not interesting, right? Okay, you locally test your Lambda, everything is okay, but this is not an application, right? Because at the moment, no one of you will be able to use this application. Let's make it more funny. I will add a trigger, specific trigger to this Lambda, and I will choose an API gateway. And now, because of the time I needed upfront to create this API gateway, and that's why I'm going to use existing API. And here I have a DevCon API created. Deployment stage, I will select test. And security, for demo purposes, I will set open. I don't recommend at all for you to set this on production. Why? Because it's like saying, hey, listen, my wife is publicly available to the entire world. It's the same thing. And I'll just click on that. Nice. So here, if you scroll a bit down, we can see that now at the moment we have API endpoint. And whenever we reach this endpoint, our Lambda is going to be executed. And if I click here, it will take 1 to 2 minutes maximum this to start working, because there are now behind the scenes some things happening. But let me give it one more try. Copy. Let me try to open it in new incognito window, and maybe it will start to work. Not yet. Not yet. A couple of more tests, and I will come later if actually it's not working. It's working? Perfect. You see hello from DevCon, right? And now, whoever reach this link, this endpoint, will see the same content. Let me demonstrate that to you. So I will take the entire endpoint, I will put it here to make it shorten, okay? Feel free from your mobile phones to reach this specific link and tell me if you're seeing exactly the same content, hello from DevCon. If you're not seeing it, it's not my fault. Is there? Yeah. Nice. Which means in less than 5 minutes, I have hosted application running. It's the dumbest application ever, hello from DevCon, but still, it's an application. And by the way, the Lambda service itself also provides us a possibility to monitor our Lambda function itself, which means it's near real time. But now if I start to refresh here, I will start to receive all of the requests from here, from the entire amphitheater that you're doing. I will be able to monitor all of the requests, actually follow, catch some errors if happen, so on and so forth. Because they're waving at me, I need to finish. I will just quickly extend the screen once again. Coming to the last slide. I promise it's the last slide. Okay, just in very quick, short words about the Lambda anatomy. Why? Because we saw that there is some code provided, so we as a developer, we need to understand one main rule about the Lambda. Each Lambda, it needs to export handler function. Why? Because that is the function that is going to be executed whenever we trigger the Lambda. This is the source, the entry point of our Lambda execution. And here from the image you can see we are using a library, AWS Serverless Express library, with which we are able to create a server, Express server, and after that, of course, in some other folders, we are defining all of the routes there, and all of that just works fine. So here we have the handler function, and as some parameters, you can see that we can always receive the event in the context. Inside of the context, we have all of the method availables, which interact with the runtime information. And for the event object, of course, here is sent all of the data sent during the evocation. With short example, we are having an API gateway. The gateway itself triggers a Lambda, right? But now in the Lambda itself, if I have a post method, let's say, I need to take the body of the request, right? So the API gateway itself provides the entire request in the event parameter that we accept here, and from there we can take all of the data that we need from the request. And thank you all. I hope we have some questions.
Thank you. Thank you, Goce, for the interesting and illuminating presentation. And I'm wondering now, who has any questions to direct to Goce? Yeah, we have a question over there. Or, well, if that's closer, you do that then. This is a free country.
I hope it won't start to work.
Okay, so I guess I'm trying to return a favor from past experience. Yeah, but good presentation. I can ask you whatever I want to ask you during the working hours. Proposal, next time use QR code instead of shorten URL, just to scan it. And a question, so all of this is good, and we know that there are all different flavors of architectures, approaches, etc., etc. We can mix and match. But when this is applicable, and what developers need to think about prior starting implementing some solution with in mind going with serverless. How the split of the code maintenance should look like, etc. What are the concerns that they need to start putting their minds and boundaries when thinking of utilizing this architecture, etc.
Okay, so of course, on the beginning, like I have mentioned, serverless actually it has its own disadvantages, and this is actually the answer of your first questions, when we should choose serverless. So as I have mentioned, with serverless we don't pay for idle, right? We pay only for value. But how the number of our customers will grow, that means that we'll have more requests coming to our application, and our bill at the end is going to be bigger than it was to be before. With, of course, the regular server full approach, let's name it, it's the opposite all around. So me personally, when I will say you should choose serverless, it's maybe at the beginning when you're building a new application. So you don't, at that moment, to manage any service, pay more money for it, and waste time on it. But after your application, let's say, comes to a specific point, you're having a lot of users, at that time, the time eventually will come whenever we say, okay, listen, serverless is more expensive for me at the moment. Why? Because I have thousands, maybe even more millions of requests, and it's going to, your bill on AWS account is going to be much bigger on the beginning. Yes, definitely.
When developing their code.
Yeah, I mean, on the beginning...
Because this is a functional way of approaching. It's not monolithic, it's not microservice or whatsoever. It's a functional type of thinking. So what is that?
Well, actually, when you talk about the Lambdas, they are not microservices, but you can see them as well as microservices. Why? Because they can be isolated completely and behave at different applications, right? But on the beginning, when you start with serverless, as you have mentioned, the developers doesn't know what to do. And fortunately, there are a lot of AWS frameworks actually that help you with helping you with the learning curve about reaching your goal, like AWS Amplify, there is AWS SAM, and a lot of other frameworks. The main goal is, I didn't have time to speak about it, Lambda as well provides you layers, which comes to your question, actually, okay, I am having 5 Lambdas, right? And they are sharing some specific code. I can create a Lambda layer, and from there I can share the same code through all of the Lambdas. So there are a lot of techniques, a lot of approaches that we can discuss how actually we're able to come to this final architecture.
Thank you for your question. We also had a question over there.
Hi, everyone. Thank you, Goce, for your presentation. I mean, it's time-limited slot, but at the end of the day, it was so insightful and comprehensive. I'm really happy that I'm knowing you, and we had the pleasure together to work in Sedaca as trainers. So, a great presentation. I just have one question. I mean, the first part of the question is already addressed, which is nice. I'm coming from Microsoft.NET ecosystem, so I'm pretty sure that the things are similar, or maybe the fundamentals are the same. My question is, do you have some experience in mixing, for example, the application services with Lambda functions? Because you can have application service or host some application with pay-as-you-go model, for example, and you are not paying for being it idle in that matter. So just your thoughts or perspective if that's doable, and if so, then what about the maintenance with this kind of approach? Because this is a hybrid approach. It's not monolith one or microservice related, or doesn't matter. The architectural approach is irrelevant here, but more your perspective about mixing the two things together.
Yeah, definitely a good question. So, of course, it is possible, and it doesn't matter if you're typing it with .NET or Node.js or whatever. So mainly you can have an application, right? And you can have your own separate services hosted somewhere on the server that you're going to manage. But from some specific things, you can use, for example, Lambdas. And you can mix both of them. And I don't see anything wrong with that, right? Because for some specific area of our application, we want to pay only for value, right? We don't want to pay for being idle. But from a different perspective for our application, then we don't care. Why? Because we are going to understand that being serverless at that part is going to be more expensive than server full, let's say. If that answers your question.
Thank you. I think it's completely addressed. Thank you.
Thank you all.
Thank you for your question. We have time for one short question maybe, and then we'll move on with the presentations.
Yeah. Can you hear me, guys? Yeah, okay. Yeah, I have a short question about, right? Yeah.
Oh,
okay.
sorry.
Yeah. By the way, is this recording somewhere? Yeah. Oh, cool. Anyway, yeah. My question would be about the versioning. So let's say that we have a version of Lambda and we want to update it to, let's say, a new version or something like that. Is there any best practice of how to migrate, let's say, from V1 to V2 of that Lambda or something like that?
Yeah, definitely there are also a lot of ways how we can have the versioning of the Lambdas. Mainly this can be done on the API gateway, not directly on the Lambda, but on the API gateway you're going to say, okay, all of that is configurable. You can even configure it from the AWS console. Also in practice, the other downside of the serverless, AWS serverless is actually, okay, in real world I have a lot of environments, right? So I won't go for each environment and create API gateway, create API, Lambda, and that's why we need something called like Terraform or CloudFormation file, whatever. And we're configuring all the configurations there, which means on the API gateway level, I am able to provide some Terraform code, which actually with that code, I will configure, okay, here I will have version 1, here I will have version 2, and whenever update change, I will also think to update the Terraform part as well.
Yeah, cool, awesome. I just have one more thing to add is that the best analogy for serverless that I've heard of till now is rent a car. So technically you're using a car, but you're carless. So you don't own a car and you pay it only as long as you use it. So yeah, thank you.
Definitely agree.
Thank you. Thank you very much, Goce, for this presentation. A round of applause for Goce one more time.